this screencast I'm going to show you how to get started with an assembly language program. So the first thing that we do is create a new bareboard project. So this is similar to what you have been doing already. We're using the same type of processor. We're using the OpenSDA debugger. Here is where it changes. So on this language page here, we choose ASM. So ASM stands for Assembly Language. So we choose that as the language that we want to use for our new project. We click Next, and there's nothing we can change here. You're not able to use Processor Expert in an assembly language project. That's only for C projects. So then we click Finish, and the project will be created for us. So let's have a look. Under sources here, we have a file called main.s, and so this is equivalent to the main.c file from before, but of course now this is assembly language code. And so there's a bit of a starter template that's actually being generated here for us. So I'll just explain briefly what's going on here. So these statements with a dot at the front are directives that are given to the assembler. So they don't correspond to machine instructions, they correspond to instructions that tell the assembler something about what is to follow. And so for example, .text here says that this part of the project should be placed into the text section. So what is the text section? That's where code is placed. So it's the flash memory of our device. So there's a section here where you can define some read-only data. So these would be constants that you could create and then refer to somewhere else in your code. So we don't actually need that here. We can actually just delete it from our file to simplify things. There's a label set up here at the top. So labels begin at the far left-hand column and have a colon on the end. Again, we don't actually need this label here. We can delete it and simplify. So later on, if you work on some more complicated projects, then you may want to use those sections, but we'll just keep things simple here in the first instance. Now we have some directives to set up the main function that's going to run. So text here tells it to be that it should be assembled into the executable section, that is the flash memory. Align to means that it should be aligned on 2-byte boundaries. In other words, the addresses should all be even. And that's a requirement of the processor. Basically, it can't load instructions from odd addresses, only from even addresses. Just they keep things simpler internally by making that sort of restriction. So you have to have the thing aligned on 2-byte boundaries. Next, we declare that main is to be a global label. What we mean by global is that it can be called from other files. Then we have the label itself, and this is where our main function begins. And there is some code here that has been provided for us. We can actually simplify this. It's doing some adds and some moves. We don't need that, so we can get rid of those. And we can even simplify this a bit further. What it's doing is pushing two registers, R3, one of the general purpose registers, and LR. LR is the link register, and that holds the return address. So it's the address that we should return to once our program is finished. Now we don't need to push R3, we don't need to preserve that. We'll come back later and talk about this in a bit more detail, but for now we can simplify this to simply pushing the link register and popping it back into the program counter. So this is the return address, and then when our function is finished, we're going to restore that return address directly into the program counter. That will have the effect of transferring our execution back to where we were called from. And again, there are some bits down the end here where you could insert some values if you needed. So this is the literal pool. This is where you could place, for example, 32-bit values if you want to load them in a single instruction. Basically, this bit here in between the push and the pop, this is where you would write your code. And so that is how we would get started. So I'll show you what it looks like if you go into the debugger. Let's just program this to the board. We have an error because I deleted that label from above. So let's simplify that, compile it, and now let's run. So in the debugger, we start here on the first line of our main function. You can see on the right-hand side the disassembly. Right now our function is pretty simple. There's not any code in the body here, so there's not much else to look at. You can go across here into registers and have a look at the various general purpose registers, so R0, R1 and so on down here. So if we just go through and step through this function, once we get to the end here, this pop program counter is going to jump backwards to where we were called from. And so if we step again, you see we end up here in some C code, which is some initialization. And so this is provided by Freescale. This is just basically sets up the processor and gets ready to call our function. So here this main was this main function over here. So basically once you get, if you find yourself here in the debugger in this file, start, that means that your function has ended, your main routine has returned, and so your code has finished running. And then there's just a while loop down the bottom that will just capture that, and so now program has ended and it will never come back and run your code again. So you probably shouldn't get to here. You usually don't want your main routine to actually end. So probably you have some kind of loop in here that continues to do whatever the task is that it should be doing. So basically that's how you would get started with writing an assembly language program.